Okay. Hi. Section 3.2, log functions. I forgot to hit record, so I'll get to where I was. We'll talk about this as I go through. You guys aren't missing anything. You'll be fine. Look at the teacher copy of notes. Okay. Here is how to do this in your calculator. I will go over this with you if you have questions. You guys can look at this at any time between now and your quiz, which is Tuesday. But if you have a question that says use the calculator to evaluate the function at the indicated value of x, literally what you are doing is saying, okay, I'm going to say -3, hit log in your calculator. If it's base 10, that's what your calculator is set in already. So you hit -3 log and then you put 2.7. What do we get when we have -3 log 2.7? Okay, so ladies and gents, we're getting -1.29 what? 4 what?
091.
40. Okay, it says to round to what? Doesn't tell you.
Nope.
So there you go. I will tell you on your quiz what to round to. If you do not round to the correct decimal place, I'm taking points off. You guys are in an honors math class in high school. You should be able to round. Okay.
So we don't do anything with that 10?
All right, properties of logs. No, your calculator's already in log base 10. Properties of logs. This is an important slide. It doesn't mean much to you with all the letters. But if I give you some examples, let's see if you can figure out what I'm saying. If I have log base 5 of 1, that equals 0. If I have log base 2 of 1, that equals 0. If I have log base 764 of 1, what do you think that equals? 0. If I was going to write this exponentially, it would be 5 to the what? 0 power equals 1. If I was going to write this one exponentially, my little 2 becomes the base, the big base, and then what happens with 0 and 1? They switch spots, right? So if I had 764 to the 0 power, what does that equal? 1. When you have log base whatever of 1, that equals 0. That is a property that you need to know. That's the same thing as exponentially. If you have any number to the 0 power, it equals what? 1. That's what that's saying. So now the second property of logs that you guys need to be familiar with is if I have log base 3 of 3, that equals 1. Okay, well if I have log base 7 of 7, what do you think that equals? 1. If I have log base 12 of 12, what do you think that equals? 1. What did I tell you that logs and exponentials are of each other? Inverses. So if I have log 3 of base 3, what happens to them? They cancel out. If I have log 7 of base 7, what happens to them? They cancel out. What is the exponent on just a plain constant? It's 12 to the what power? 1. So that's why it's just 1. Make sense? All right. If I have this as an example, log base 13 of 13 to the 15th power. What happens with log base 13 to 13? It cancels out. What's my answer? 15. If I have log 4 of 4 to the 3rd power. Okay, what does it become? What's log base 4 times 4? What happens to each other? They do what? They cancel out. So what does that become when they cancel out? It doesn't go away. It becomes what number? 1. And then 1 times 3 is?
3.
That's why. So log base 13 of 13 to the 1,474th power. 1,474. Good. All right, those are extremely important properties because you're not going to sit there and be like, oh gosh, I have to figure it. You guys should just recognize that. We're going to use this property in 3.3 to 3.4. But if I have like log base 2 of x squared minus 9 equals log base 2 of x plus 3. Does anybody know how to solve this?
Oh, you simplify, or you do the factor.
What do we have to do first?
Factor.
Maria, what do I have to do first? No, what did you say? Cancel out what?
Log.
No.
Why? Why?
Because there's 2 of them.
There's 2 of them, but where are they? Where are they?
On opposite sides.
They're on opposite sides. They're the exact same log, correct?
So you subtract.
So you can cross them off, and then what do? You set whatever's left over equal to each other.
To each other.
So like guys, same concept. The other day we did this. 3 to the x plus 4 equals 27. How would you solve this? What do I have to do first? Yes, you do.
I don't know.
Yes, you do. Are the bases the same? Can I get them to be the same?
Yeah, multiply.
No. Well, what do you mean by multiply? How can I rewrite 27 with 3 as the base? 3 to the what? Third power? What do you notice about the bases on both sides of the equation? What do we do when the bases are the same?
I'm confuzzled.
You guys cancel them out. So it's x plus 4 equals 3.
Oh.
We did that in section 3.1. So guys, this is the exact same thing. It's just opposite because now we have logs. Same thing.
Wait, so I know my answer. What's the answer? That's equals.
Okay, so moving on. Think about this exponentially. Before you guys, it just says solve. It doesn't say to rewrite it exponentially, but exponentials and logs, they go hand in hand. We're talking about exponential. What is the relationship between 3 and 81? God bless you. Exponentially, what's the relationship?
Wouldn't it be 3? Or no, 4.
What's 4?
Like 3 to the 4th power.
3 to the 4th power equals 81. Right, so you just solved that x equals what?
4.
X equals 4. If I rewrote this exponentially, I'd say 3. What happens with 81 and x? They switch. This becomes the exponent. This becomes the answer. So you are solving for x. But you guys can do this in your head. I'm going to need you to rewrite it from logarithmic to exponential and vice versa. But that gives you kind of an idea because you can see the relationship between the two numbers. Log 5 of 1 equals what?
1 or 0.
Which one is it?
0.
0. Because 5 to what power gives me 1? Your answer would be 0. So you can solve these things in your head just by kind of thinking, rationalizing. Then it's easier to say, oh, okay, I see where my exponent goes, I see where my answer goes. Something like that. All right. Don't fail me, guys. Look at A. 3 to the log 3, 15. What cancels out? 3 log 3, so my answer is 15. Very good. It's nice to know our properties of logs. Log base 2 times 2 to the 3rd power.
3.
What happens? These cancel out. My answer is 3. What 9? This is to the 1st power, correct? What happens when I have log base 9 to the 9th? Cancels out. Becomes 1. Ooh, this one's tricky.
What the heck? It would be negative 1.
Rewrite 1/3. How can I rewrite 1/3 with an exponent? 3 to the what? -1, right? So log 3 and the 3 cancel out. I get -1. Every time you see a fraction, guys, I told you to remember negative exponents. If I had 1 over 6, how would I write that with a negative exponent? 6 to the what? To the -1. This is to the 1st power. When I move it up, it becomes negative. Okay, good. All right, now we're going to talk about the graphs of logarithmic functions. Here in the blue, this is my exponential. It's 2 to the x. It's a nice smooth curve. It's increasing. Everybody see that? My intercept is at y equals 1. My horizontal asymptote is at y equals 0. Inversely, I have my logarithmic. Do you see how all it did was flip over that y equals x line, just diagonal? So everything we know about our exponential is the opposite for the log. My domain for my exponential function is all real numbers, negative infinity to positive infinity. So instead of the domain being all real numbers in exponential, in logarithmic, all real numbers goes with what? If it's not the domain, it goes with the range. My range for my blue smooth curve is 0 to infinity. So what's my domain for the red one? It's 0 to infinity. It's the same thing. It just switches. We talked about this at the beginning. Look, I have exponential. My domain is negative infinity to positive infinity. My range is 0 to infinity. Doesn't move up or down. In my logs, it's switched. Your domain is 0 to infinity, and your range is negative infinity to positive infinity. We have a horizontal asymptote at y equals 0. Well, instead of having a horizontal asymptote, what's the other axis? Vertical asymptote. This one has a vertical asymptote at x equals 0. Do you see how it's just the opposite? If you are given a domain, here's my domain and range for my exponential function. Here's the domain and range for the inverse or the logarithmic. What happened to the x's and the y's? They switched. So all of the stuff that you know for exponential just switches spots. That's it. We talk about logs. All right. It's kind of stuff I just went over. Exactly the same thing I just went over. Again, this is the same thing I just went over. For a log function, it reverses the domain and the range from your exponential. Your range is the negative infinity to positive infinity. Your domain is the 0 to infinity. Instead of our exponential shifts up and down, so our logarithmic shifts which way? If our exponential goes up and down, what would the opposite be?
Right and left.
Right and left, horizontal shifts. In order to find your vertical asymptote, you set the parenthesis equal to 0. And to find the x-intercept, you plug in 0 for y. We've done that before. I'll show you this. You guys will be fine. Transformations. Are these transformations familiar to anyone?
Yes.
Yes, it's the exact same transformations we've talked about with linear, quadratic, cubic, rational, square root, absolute value. All that. Exponentials. If I want to take my logarithmic function and move it up or down, I add or subtract a number at the end. If I have a logarithmic function and I want to move it left and right, I put it in parentheses with the x. If I want to reflect my logarithmic function, if I put a negative out in front, it reflects over x. If I put a negative inside the parenthesis, it reflects over y. There you go. If I want to vertically stretch or compress, I'm going to multiply out in front. If I want to horizontally stretch or compress, I multiply where? Inside the parentheses. Same things we've talked about 152,000 times. All right, I'm not going to graph this 100% right now, but do either of these move left, right, up, or down?
No.
No. What is this function?
Exponential.
It's exponential. It's an increase. Right? It's increasing. It's a growth. What is this function here? Logarithmic. It's going to come this way.
Is that always
How do you know that?
Because it reflects over that line. If you did a table of values, you would know that, but you should know the general direction. It's a positive, right? There's no flipping or anything. So our positive growth curve gets really, really close to the y equals 0 and just gradually goes up. Our inverse, the logarithmic, gets really, really close to x equals 0 and goes up. Yes, ma'am?
is log always going to be decreasing or like?
Okay, so let's talk about graphing some things. First of all, I don't even want to graph this one. I want you guys to tell me what's happening to it. Okay, how do you know it's right 1? Perfect. It's going right 1. And what else?
Across the y.
It reflects across.
Y.
Okay, you pick one.
That's
Y.
X.
Across the x. Good.
Damn.
Inside, it's with the y.
Praise Jesus.
Okay, here we go. All right, let's look at this one. You guys are going to have questions on your quiz that ask you all of these questions. They say for the logarithmic or natural log, we'll talk about that in a second. It's the exact same thing. Find the domain, the range, the vertical asymptote, and the x-intercept. Okay? So when I'm talking about logarithmic functions, exponential, my domain is negative infinity, positive infinity. So that means with logarithmic, what's negative infinity, positive infinity? The range. Very good. If I have a vertical asymptote, it's going to be at x equals or y equals? X equals. So look at this, guys. X equals is my vertical asymptote. Our vertical asymptote and our domain go hand in hand. It's the x-axis. So on that last slide, I just said a couple slides ago, I said, how do you find the vertical asymptote? What do?
You plug
Set
to 0.
Set what equal to 0?
X minus
The
5.
parenthesis. You say x minus 5 equals 0. So I solve this. I add 5 to both sides, and I get x equals what? 5. So what is my domain, Miss Mia?
5 and infinity.
5 to infinity. Good.
How would you find the x and
I'll show you in 1 second. Hang on. Here's my asymptote at 5. 1, 2, 3, 4, 5, right? There's my asymptote. Now, to find the x-intercept, well, how do you find x-intercepts? You plug in 0 for what? For what? For y. So I have log 4 x minus 5 equals 0. Now, to solve any equation, use inverse operations, correct? Right? If it said 5 times x, you would divide both sides by 5. If it said 5 plus x, you'd multiply, or 5 plus, you'd subtract. What is the opposite or inverse of log base 4?
Oh, the exponential.
Exponential. So I'm going to put a big 4 here, and then everything goes up into the exponent. Actually, no, I'm not even going to do it that way. Hold on. If I make this exponential, right? I make this, my little 4 becomes a big 4. And what happens with x minus 5 and 0?
They switch.
They switch. So this becomes 4 to the 0 equals x minus 5. Well, ladies and gents, what is 4 to the 0?
1.
So x minus 5 equals 1. What do I do to both sides? Add 5. So x equals
6.
So I now can graph my function because I know that my asymptote, that it's going to get really, really, really close here from the bottom and then go up, is at 5, and it's going to cross at x equals 6. So watch, you just start here. You get really close to this asymptote, and then you just go through the x-intercept, and there you go. Look at your domain. What did Mia tell us our domain was?
0 to...
No, our
My
domain.
bad. Infinity. Negative infinity.
Our domain.
5 to infinity.
5 to infinity. Is that what our graph is showing? Yes. Okay, good. Natural logs, same thing. Same thing. You guys are fine. If I said to you, evaluate this, you'd say 2 in your calculator, ln 12.5. If you don't see the ln button, it's on the same button as e to the x, but can someone tell me, please, what 2 natural log of 2.5 is? Gentlemen, so when we evaluate this in our calculator, we get 5 points.
0, 5.
0, 5,
1, 4.
1, 4. I want to go to 3 decimal places, so I go to the 1. What happens? Do we raise it or stay the same? So 5.051. You will have at least 2 questions on your quiz that say evaluate. If you don't have a calculator, you don't know how to use it, you will get a 0. You will not get it right. You have to have only scientific, no graphing. Properties of natural logs are the same as our properties of logs. So if I look at this, I have negative 5 natural log e. ln and e are what of each other? They're opposites. They're inverses. So they do what? Cancel out. What's my answer? Negative 5. E to the natural log is 7. E and ln are what of each other? Inverses. So they cross out. My answer is 7.
What are the inverses?
Excuse me?
Oh, because, okay.
Like exponential and logs are inverses.
Yeah.
E to the x and your natural log are inverses of each other. All right, let's do this last one, and then we'll talk about your web assigned stuff. I want to find the domain, the x-intercept, the vertical asymptote, and I'm going to sketch the graph. So I'm going to find my domain. I'm going to find my range. I'm going to find my vertical asymptote, and I'm going to find the x-intercept. Okay, so for exponentials, my domain is negative infinity to positive infinity. But for logarithmic and natural logs,
It would be 3.
what's negative to positive?
Range.
Range. Negative infinity to positive infinity. How do I find my vertical asymptote, which goes hand in hand with my domain? Set parenthesis, good. X minus 3 equals 0, so x equals 3. So I have a vertical asymptote at x equals 3, so that means my domain is 3 to infinity. Questions? Okay, let's draw our asymptote.
I have a question.
Yep.
For domain and range, is it the same as...
No, she said switch.
Same as what?
Like the infinities.
Are you asking me if it's the same as log? Yeah.
Wait, isn't that log? Oh, that's
Same,
ln.
same thing though. Same characteristics are the same.
Okay.
Characteristics are the same. Okay, so now that I've found those things, I need to find my x-intercepts. Well, how do we find x-intercepts?
You set everything else.
Okay, so natural log of x minus 3 equals 0. So, ladies and gentlemen, what did you tell me the opposite or inverse of natural log is? E. Right? So if I put an E here and then I raise everything, we did this last year, we'll do more of this for solving. I'm just showing you. I put my E so I can undo the ln and everything goes in the exponent. If I do that on the left-hand side, what do I do on the right-hand side?
Do it again.
A big E to the what?
Right side.
What is it raised to the what?
0.
0. Good. So what happens with E to the ln? Cancels out. I'm left with x minus 3 equals 1. Anything to the 0 power is 1. So I add 3 to both sides, and I get an intercept at x equals what? So look, here I draw my x equals 4. I know that my function is going to get really, really, really close to that vertical asymptote, but not touch it, right? And it's going to continue to get bigger. I'm going to continue to use those x values. So I'm going to come real close to this line, go through my x-intercept, and then that's it.
Is it always going to be the one number to the right of? Oh, okay, so one cell.
It's a good way to check it, though. Okay. We okay? All right, so. Okay, that's everything from the lesson. All right, good. I will upload this in a second.